Okay, so every time we are looking at graphing a sinusoidal function, first things first, let's identify a, k, d, c. But because this is sinusoidal, the letters a, k, d, and c play it does something very interesting to the graph to the point where it's so useful to use them as little shortcuts or little tips to draw it very, very quickly. Now, that might not mean anything or it might not even make any sense, so I am going to demonstrate it instead. The A value, the K value, the D value, we have to do something about, and the C value is right there. What is the problem I have with the D value right now? Someone want to share?
It's actually a negative.
Not that it's, well, yes, you're right. It would be technically negative 45 degrees. However, true to what I've always been talking about with functions, the k value, I will often give you the k value not factored from the x variable. So in reality, this equation should be f of x equals negative 2 sine. The half is, um, I guess, factored out, leaving me x plus 45 divided by half is 90 degrees. Okay, which means my A and K and then D and C, I can take it at face value from the equation. Okay, we have to factor it. Yeah, you're right, Alex. Sorry, I didn't even see that. Okay, so from here, before I draw it, I'm going to talk a little bit about its properties. That's down here, all the stuff here. And then we'll hammer it out one at a time. Let's figure out what these numbers represent just in terms of properties. First off, amplitude. Wow. Amplitude. Again, because this is the first instructional, I'm just going to go straight into it. Amplitude, if you remember, is represented by the vertical stretch. Remember, a sine function is basically this, starting from 0 and ends at 360 degrees. The highest point possible would be a 1, and the lowest point possible would be a negative 1. If I have a vertical stretch of 2, that means that my maximum of 1 is multiplied by the negative 2, and the minimum of negative 1 is multiplied by negative 2. Essentially, my amplitude is what's changing. I go really low, I go as low as negative 2, and then when I come back, I go as high as positive 2. So that A value is going to be my amplitude. And of course, we write it as absolute value. My amplitude is a 2. Okay, let's move on. I'm going to leave period last because we have to do something funky with the K value. My phase shift. I know that my sine curve starts from 0, but this phase shift moving to the left of 90 degrees tells me, it's very, very vaguely, where one cycle begins, right? So the word begins is a little bit of a misnomer because sinusoidal function, it continues forever. It goes from negative infinity all the way to positive infinity. Because of that, for sinusoidal functions, all we're trying to do is capture one snapshot, one cycle, one period, and we can copy and paste that everywhere. So when I say begins, it simply means where one cycle out of the million cycles out there, where does it begin? So a plus 90, as we said, I think it was Kennedy that said it's supposed to be negative. I am moving 90 degrees to the left, right? I'm moving 90 degrees to the left. That's what's going to happen. So my phase shift, I'm going to say it's negative 90. The same way, vertical shift, is a 2 plus. And instead of just talking about a vertical shift, this is what the tip or the trick that we can use. This is the trick that we can use to graph the function. A plus 2 means not only is the entire function, but the mid-axis, the dotted line that we always return to after hitting a maximum, we go back to the mid-axis. We hit the minimum, we go back to the mid-axis. That mid-axis has been shifted. That's going to be 2, right? So I know our vertical shift is 2, but it says a lot more than just putting every single dot upwards. Lastly, my period is um, is determined by the k value. If you remember our previous lesson, the formula old over new, or rather old over the k value gives me my new period. So the old period is 360. My k value is 1 over 2. So 360 divided by 1 over 2, that's the same as multiplication of 2 over 1. My period is 720. We'll fill in the domain and range after we sketch it because it's a lot easier to visualize then. I'm going to stop right there to make sure everyone is caught up with our numbers. Before I even graph it, I think it's a good opportunity for everyone to remember or try to remember where we got all of these numbers below: amplitude, period, phase shift, vertical shift. I'd like to give you an opportunity to ask questions. Anyone? Do you have a question?
I have a question.
Yes.
Why is the A value absolute and none of the other ones are?
Ah, well, think about it this way. Remember, on a regular, I guess, the parent function, you know that for sinusoidal, let's say that's 90, and that's 180, and 270, and 360. Okay? You know that it's supposed to hit a maximum and come back down. And then on the bottom, I hit a minimum and come back down. Right? The distance we move away from the mid-axis, right here. And the distance we move away from the mid-axis. I know the direction is up or down, but the value in which we're moving we're going to refer to as a positive, right? And that's the only reason why we use the absolute value. There's no need to talk about it. Like for example, let's say I have a negative 1. That means my new curve would have been down here because it's a reflection, right? But guess what? If I continue this line, because you know that a sinusoidal function goes on forever, well, why do I have to refer to this section? Why can't I refer to this section? If I refer to this wave, this particular period, I went up and then I went down. It's as if I didn't have a reflection, I just had a phase shift. So long story short, there's no real need to talk about an amplitude as a negative because even if we refer to it as a positive, it already tells us how much we go up and how much we go down. Is that
Um,
enough of an explanation? Is that okay?
I have a
Yeah.
question.
Yes, go ahead.
So is this amplitude is it measured based on the x-axis or just from the midpoint? Because if you do like the +2 at the end
Mm-hmm.
and you raise it,
Mm-hmm.
then the x-axis amplitude isn't going to be 2. It's going to be in this case 3 or sorry
Uh,
4.
you're mixing up the word amplitude with max and min. Amplitude means from the midline how high or how low we go.
So it's the midline but not the x-axis.
Yes.
Okay.
You'll see what happens, okay? So here we
Okay.
go. This is my parent function. No, these are really good questions. Thank you for asking them. Starting off, just as James was saying, my vertical shift is +2. And so right now my midline is right here. But if I were to shift the entire thing up, then my midline would be right there. And I realize now that I might not have enough space. That's okay. I drew it. I'm going to take responsibility for it. So my midline used to be at 0, 0. Now we have the midline at 2. And yeah, let's pretend that my stretch isn't there yet. Like I would have to go up by 2 from here and then down by 2 from there. Like that's how it would work with the amplitude. Okay? Now let's continue. Let's continue. So there's a lot of different ways we can start this. Some of you might want to keep it the same system as before. So again, how about we go from left to right? The proper way of applying a transformation is to do the stretches first and then the shifts later. So let's go left to right. But I think it would be useful if we do the K before the A this time. Okay? So bear with me. Ready? My K value is a period of 720, which means it's not 360. I have to go as far as 720 to finish my curve. It's going to be something like something like that. Next, a vertical stretch of -2 means my amplitude isn't at 1. Sorry, my maximum isn't going to be at 1. Let's use a different color. It's going to be at 2 and -2. So far, so good? So take a look. My mid-axis is still at the x-axis. My max is up at 2. My min is down at -2. Do you see how I've essentially created a roof and a floor for myself? Now let's move that around a little bit. So my roof and a floor, essentially, I know that my graph, my curve, has to be within these boundaries. My curve is going to be somewhere in this box. Right? Let's keep moving. I have a phase shift of 90 degrees to the left, and my vertical shift is 2 up. And so I'm going to keep this box. In drawing this box, I just said that, or we just established, that my curve has to move 90 degrees to the left and 2 up. So my curve is supposed to be inside this box, but that entire box will be shifted 2 to the left and 1 unit, 2 units up. I just draw my curve here. I'm gonna do it accurately, but I just want to show you how easy this is going to become. I know that my sine curve starts in the middle, ends in the middle. There's a point in the middle. There's going to be a max or a min between these two dots. There's going to be a max or a min between two dots. All I have to do is fit a curve inside that box. Okay. I see chat. I'm having technical difficulty. That's okay. I don't hear anything right now. So, again, let's talk. If I were to apply my period, my horizontal stretch from my parent function. Okay. If I were to do a horizontal stretch, it would be all the way to 720. So your new graph would look something like this. Okay. So it would look, I'll use blue, 280, 360, 540, to 720. So let's say you didn't want to calculate. What you can do is, remember, where does my curve start? It starts at 0. Where does my curve end? It starts at 720. Where is the midpoint? 360. Where's my max? Between the first two dots. Where's my min? Sorry. Between the last two dots. And it will be next. Vertical stretch, -2. If I were to apply a stretch of 2, the maximum would have to be up here, and my minimum would have to be down to -2, right? So my next curve would be, same idea. I start at the 0, but I multiply everything to 2, 0 times 2, 0 times 2, 0 times 2. Here. Let me try to do it in one curve. Oh, there you go. Okay. I really wish I was in front of you so that I know how far people have gone to sketch this. Right? From here, all that's left really is to, what do you call it? All that's really left is to take this curve that you have, move it 90 degrees to the left, that's 90 degrees, and then move everything +2 there and there. And that would be your final curve.
Mr. Kim,
Yep.
would the -2 mean you have to reflect it or no?
Yes, you're right. I totally forgot about that. Jeez. Thank you for reminding me. So if I don't have a reflection, so I don't have a tool to do reflection. So you're right. This would mean that now I'm at a negative. There it is. And then that will then be reflected. That will then be shifted 90 degrees to the left and 2 up. -90 degrees to the left and 1, 2 up. This is 90 degrees, 1, 2, 3, 4. And 90 degrees, 1 here. 90 degrees, 194, and 90 degrees, 194. Oh man, this tablet, jeez. Okay, I'm really having some trouble graphing this, but I think you get my point. Okay, so I went through the same system of AKDC, but it's a little grueling, right? It's the same system, it's a little annoying. What I wanted to show you was a very interesting, very efficient trick that helps you draw a sinusoidal curve very, very quickly, as opposed to going through AKDC. The reason why we can do this for sinusoidal functions is because it keeps on repeating. Okay, so I would like to erase this. You can keep what you have, but I'd like you to listen. I'm going to erase all this and do it again using some logic. Okay, and once you see it once, I'd like us to try the same method later on. Okay, with my example 2. But just to finish off, domain and range. The domain of any sinusoidal function would be xer, and the range would be yer, but in this particular case, my y goes as low as 0, y, and as high as 4. Right? Okay. I'd like everyone to be on the same page, so I'm going to erase this very, very soon. How much time do you need? Just a couple more minutes?
I have a question
Yes, go for it.
about the graph. Why is it at 4? Like, why is the range 4?
The range is 4 because the amplitude is a 2, and I've moved up by 2. Right, so when I draw it like this, it's a little bit confusing, isn't it? Okay. Bear with me. If you take a look at the pink line, I go as low as 0 here, and I go as high as 4 here. So my range is 0 to 4. But this is why I want to show you, this is why I want to show you this little trick that I have for you. It's something that my sister taught me, I think, when I was in high school and she was in university. It just helped her a lot. So I want to show that to you. Okay? Let me clear this. I'm going to clear everything and redo it from the start just to show you how easy it can be. I have my function to be f of x equals -2 sine half x plus a 90 plus 2. My amplitude is going to be 2. My period is 720. My phase shift, -90. My vertical shift, plus 2. I am going to, just for the sake of simplicity, my y values are going to be in 1 increments. This is still going to be 2 boxes for 90 degrees. 540, 720. Okay. Just listen, see if this is up your alley, and then if you like, apply it to the next example. If you don't like it, just do what we've always been doing, just do AKDC. Left to right. All right? Number 1, using a highlighter. Initially, my vertical shift, right here, is my mid-axis is supposed to be here. However, because there's a vertical shift, my mid-axis goes from 0 and it becomes 2. All right? Show me a thumbs up. Does that make sense to you? You can also type Y in the chat. Okay, let's keep going. Next, my amplitude, let's use green this time. My amplitude is going to be 2. Forget the negative. I know that whether I start negative or not, from that mid-axis, I'm going to be going up by 2, and I'm going to be going down by 2. Right? I'm just purely using logic here to try to draw a picture. So if you don't follow where I got that idea, please let me know. I'm going to try to color coordinate this. so that you know which lines you understand and which dotted lines you don't understand. Next, I know that my sine curve is supposed to start at the midpoint and it's supposed to go up and down and whatever, right? It's supposed to go from the midline, it's supposed to go up and then down in that way. If I had a vertical shift, I would expect to also start from the midline, go up and down, and then end at the midline as well, right? So I know my starting point is supposed to be here, but I have a phase shift. My starting point is not at the y-axis anymore. My starting line is at negative 90 degrees. Okay. As well, I need another color. How about I use pink? My period was supposed to be 360 if I started here. I'm supposed to end at 360, but because of the period horizontal stretch, my period is now finishing at 720. But remember, I went from 0 and I shifted 90 degrees to the left, so where I end should also shift 90 degrees to the left. If my dotted line, this orange dotted line or red dotted line, is supposed to be at negative 90, my finish should be just before 720. It should be at 630 as well. Okay, and that is this color. So in recap, the vertical shift tells you where the mid-axis is. The amplitude tells you on what I'm going to call the roof and floor, okay, of my wave. The phase shift tells us where I'm going to start my cycle, and the period sort of tells us where I end my cycle. Does everyone sort of see this box that I drew using just basically logic? And what's so special about the box? Well, a single cycle, one cycle has to fit in this box. Let's do it. My sine curve, I know it has to start from the mid-axis. My sine curve, I know it has to end at the end of the box at the mid-axis. And since this is a sine curve, I know that perfectly in between the front and back, or the first and last point of my sine curve, has to have another point in the middle, in the mid-axis. Between the first 2 points, perfectly in the middle, there's got to be another point here somewhere. And between the last 2 points, there's got to be a point here somewhere. Remember that the amplitude, or rather the vertical stretch, was a negative value, which means I don't go max first, I am going min first. And then between the last 2, I'm not going min, I'm going max. This is my transformed sine curve. I think it's a lot more organized and it's less messy and you don't have to draw like 5 different lines at once. I really like it. If you don't, that's fine. Just use what you learned before with AKDC. But if you use a little bit of logic, each of these numbers will help you draw one of the walls of my little box. And if you have your box, you can again use your logic to fit in the 5 accuracy points, and away we go. Do you have to draw all the transitions? I'm going to say if you use this box method, you do not have to draw the transitions. It's sort of redundant. It defeats the purpose of using a different strategy. So if you like this color coordination business, I highly recommend you do it. And Monica, this is why I know that I started at 0, so my lowest point is a 0, and my highest point is a 4. And so that's why we can say, hey, the range is going to be 0 to 4. And we don't have to worry about all the mess from before. Does that help to clarify stuff?
Yeah, no, I understand.
Okay, perfect. My drawing before was really messy, so it doesn't help either. Okay, I'm going to go to number 2. I would like you to, we're going to hammer out AKDC together, and then I would like you to try to draw the sketch using amplitude, period, phase shift, and vertical shift the way you want to do so. Okay, here it is. I'm going to make a quick edit. An amplitude of 1/4 is really annoying, and I don't want you to draw, I don't want to get into just sketching issues when we're still learning it in the beginning. Let's pretend our amplitude is a 3. And I want us to start, well, let's talk about it. Okay. So our amplitude of 3 means my A value is going to be a 3. A period of 600 is going to help us calculate K. A vertical shift of 2 minus 2 is going to be there. And my D value, it could be a 0, it could be something else. Take a look at what the question says. The graph starts at a maximum. May I remind you that a sine curve starts at the mid-axis, whereas a cosine curve starts at the highest point before completing a full cycle. And so if the graph is saying it starts at a maximum, we have two choices. We could either take my sine curve and shift it over to the left so that I start, my y-axis begins, it's at a maximum, or we can choose to use cosine, where by default I'm starting at a maximum. So to begin, let's choose cosine, which makes me not have to do a shift. And my k value, if you remember, is old period divided by new period. Old period divided by new period. If I simplify, that becomes 6/10 or 3/5. The equation I would like you to sketch is, I don't have any space. F of x equals 3 cosine 3/5x with no d minus 2. Oh, sorry, Alex. I made an edit to the sheet. I don't want you to do 1/4. It's unnecessarily messy. Amplitude is going to be 3. Okay. So we have amplitude, k value, so my period is 600. My d value you don't have to worry about, and my c value of -2. Go ahead and sketch it in any way you want. But if this was a test, like a test question or whatever, I would expect you to be able to do this within minutes. So I'm going to give you until 2:45. At this time, I am going to not only pause the recording, I'm going to pause the screen, and then I'm going to put my answer in there. And then once you're ready, I can reveal to you what I have been drawing. Okay, resuming recording. It's about 1 minute away from what I said. So I'm just going to resume sharing, and I'd like you to compare what you've gotten so far with what I have here. Okay, so take a look. I have created a box where I'm going to fit a single cycle, and this is my logic. I have my vertical shift be -2, so my mid-axis was moved 2 down. And normally my amplitude would be up 1 and of course down 1, but my amplitude or my vertical stretch is now 3. So my roof of the box has been moved 3 units up, and the floor of my box has been dropped 3 units down. So I have my midline, I have my top and bottom of my curve. Next, all I have to look for is the vertical start and stop of my box. Where am I starting? Well, there is no horizontal shift, so I can start at the y-axis. Next, I have to have a period of 600, and so I counted out 600 right here. I drew the end of my box. All that's left for me is to remember that this is a cosine curve. So here goes. Cosine begins at a maximum before coming back down and then finishing off at a maximum again. So in this box, I have to start at the maximum of this box. It's in the top left corner. And if I go through the entire cycle, I should finish at the top right corner. I'm also going to continue using my logic and say my minimum has to be perfectly in between it. And what is perfectly between 0 and 600 degrees? It would be 300 degrees, right there. And it's a minimum, so I have to hit the bottom of the box. Oops. We'll finish off. Between the max and the mid, perfectly between 0 and 300 degrees, I need to hit my midline. As a circle, it's got to cross the midline, right? So 150 is the direct middle between 0 and 300, and 150 is right here. I'm going to put a dot on my midline. And the location between 300 and 600 is 450, which is already labeled. So I'm going to have a dot on the midline. And then from here, I will make a nice smooth curve to connect the dots. That wasn't a very good curve. Very neat, very clean. Any questions? Or if your curve seems to be a little different from mine, ask a question about which part looks different and why. Let's address it right now. Sorry if you heard that baby crying. No questions? Okay, well, if that's the case, you are free to choose whatever method you feel is helpful to you. I want to use this opportunity to not only write our function as f of x equals 3 cos, oh, I already wrote it. I want to use this opportunity to talk about what if this was a sine curve. I'm going to erase all this. What if I decided I wanted to use a sine curve? How do we go from a cosine to a sine? Well, here it is. If you remember, once again, a cosine is starting from the maximum. A sine starts from the mid. If I had to change a sine into cosine, I would have to take the sine and shift it to the right. Because if I do so, and remember, the curve continues, I have effectively created a cosine curve where I start at a maximum. Right? So to go from cosine to a sine is simply a shift 1/4 of a cycle to the left. Sorry, back to the right. I'll say that one more time. Right now, so how about I go backwards? Right now I have a, let's use a color. Right now I have a cosine function. But what if I said this originally was a sine function? Oh man. Originally this was a sine function. And the sine function was actually here. What did I have to do to this pink curve to start the curve at a maximum at the y-axis? I had to shift my sine curve 1/4 of a cycle to the left. Does everyone see that? So if I were to change this into sine, it would be f of x is 3 sine I'll make the point again. If I left my equation with just x, my curve would start at just the midline. But since I'm moving it 1/4 of a cycle to the left, I am adding 150 degrees to the equation. And please recall, I'll write it in black, of a okay, the 150 is 1/4 of a period of 600 degrees. So I'll say this. That is my answer to number 3 if you take a look at the question. I wanted to address it because it's asking you to write a sine function, and this is the difference between a sine and a cosine. It is 1/4 of a period. 1/4 of a period. So for number 3, I'm not sure if you can see this, but to go from sine to cosine, the sine function must be shifted 1/4 of a period to the left to become a cosine function. Let's see if I could turn that into a different color so that you can see the difference. Green. Red. There. The sine function must be shifted 1/4 of a period to the left to become a cosine function. What is the period? Well, it used to be 360. That's why we've always been talking about a 90-degree shift. But if I change the period, the shift has to also accommodate for that period. Any questions? Let me take a look at what's next. Okay. No? All right. Well, this is basically I guess the last official lesson before we try to apply it in different things. And next time I see you tomorrow afternoon, I'm going to run through an in-class activity that we were supposed to do in class. It gets you to use desmos.com as a thing. So I really want to make sure you're able to at least translate even word problems into AKDC. So I have an example problem I'd like to give you. I'll draw a little picture for you, and from there you can see if you truly understand it and if you're able to graph it. You may need grid paper. If you don't have it, you can just make a quick sketch to see if you understand it. You don't have to have an accurate depiction or a drawing to have a correct equation. So here it is. I'm going to start sharing a whiteboard. Here's my question to you. Mr. Kim is riding a float on a lazy river ride. Okay, so I'm on a little tube. Oh my gosh. Oh my gosh. All right, I'm on a little tube. The water is 1.5 meters deep. The motion of the water causes the float to rise and fall 10 centimeters above or below the water rested water level, I guess. If the ride started at rested water level, oh, I also forgot. Rested water level at a rate of 30 times per minute. If the ride started at rested water level, write an equation that models the height of Mr. Kim using a sine function and a cosine function. So it's almost 3, so I do want to give this a shot. I want to give you a chance to do this. I'll give you about 5 minutes. We'll write it up together, and then the rest of the time is just homework time, so we'll dismiss. Okay? Give it a shot. I'm going to pause the video, and we'll come back in just a sec. Actually, again, maybe it's because it's the first time we're doing it. We should work this out. Water level, 1.5. I am rising and falling 10 centimeters. Okay. And I'm going up and down 50 times per minute. And then write an equation that models the height. Okay. Here. Let me start it off. Here's the floor. And on top of the floor is water. And then on the water is like a tube. Okay. And on the tube is Mr. Kim. Clearly, I'm not having a good time because it's making me motion sick. Okay. The water itself is about 1.5 meters. It says it in centimeters, so how about I just change this to 150 centimeters? Okay. I'm going up and down from rested sea level, rested water level, and I'm going at a rate of 30 times a minute. Let's see if you can visualize a wave function from this scenario. I'll give you about 5 minutes. Okay. Let's see. Going up and down. Okay, let's just get started. Rising and falling, get very, very quick, is going up and down like this, in this kind of motion, which means my amplitude is going to be a 10. At the same time, the wave continues to go above and below at rest at sea level, which is 150. So you can safely say that my C is 150. My K is going to be calculated using the number of cycles we have completed per minute. So if it's 30 times per minute, how long is one cycle? What is the period? Right? What do you call it? If it's 30 times, so 30 cycles per minute, you can say the minute is equal to 30 cycles per 60 seconds. So just reduce it. It's 30 over 60. I complete one cycle in 2 seconds. My new period is 2 seconds, which means my old period divided by new period is equal to 360 over 2. That's 180. What does that mean? My K value equals 180 and my period is 2 seconds. Okay. So what's my phase shift? Well, it says if the ride started at rested water level. What does that mean? Does that mimic closer to my sine curve? Or does it mimic closer to my cosine curve? I think it makes sense that we say it mimics the sine curve, right? Oops. All right. So all in all, if we put all of this together, we have f of x equals 10 sine 180 x minus a 0 plus 150. And it would look like this. 150. That way, that's the 1 second, that's 2 seconds, 3 seconds, 4 seconds. I go up to 160. I go down to 140. I start at the midline. I finish at the midline. I have to hit the midline in the middle. Between the first two dots will be an up. Between the last two dots will be a down. There it is. Any questions about the sine function? I'm really hoping there's a sort of like a logical progression to this, and the silence is not because you're lost, but the silence is more because it seems pretty straightforward. Okay, there's one last thing to the question. How do I change it to a cosine function? And remember, a cosine function is supposed to be starting at the maximum. So again, let me maybe use a highlighter. I'll draw a nice pink one. And here is what a cosine function is supposed to look like. It's supposed to be like that. If I want this cosine function to mimic the sine function, I have to move this so that my maximum aligns with the sine curve. So how much of a full period did I have to shift to the right? It's a magic number. If I want to go from sine to cosine, I have to shift 1/4 of a period. Well, how much is a period? That much. So if I want to go from sine and turn it into a cosine, I have to attribute, or I have to take into account that I am shifting the new period of not 360, but in this case, 2 seconds. And if I move it to the right, I essentially have the same curve as the sine function. Would anyone like me to clarify any parts of this question? Again, I hope I did justice to this. If you take a look at some of the questions in the textbook that are assigned at the bottom of our sheet, you should see some entry level and some medium, moderate level difficulty questions. Please try it. It will not only help you with word questions and whatnot for the test coming up or the quest coming up, but also it will help you sort of understand your little in-class assignment better tomorrow. Okay? Um, Also note, maybe tomorrow, since the lesson itself is relatively short, I can start off by giving you maybe another Ferris wheel style question that might mimic or that might help you model using sinusoidal functions again. And as a big hint, on the quest that's coming up for chapter 4 and 5, for the sinusoidal section in chapter 5, I am going to give you an elaborate Ferris wheel question. So try the homework today after you give yourself a break. Get used to reading sentences or reading questions, converting them into equations and graphing them. And then tomorrow, right at 2 o'clock, I'll have a Ferris wheel style question waiting for you for your minds on. Okay? Final questions or concerns before we dismiss?
I have a question about the assignment.
Sure, go ahead.
Is it due tomorrow?
You're talking about which assignment? The triangle assignment?
Yeah, triangles.
The triangle with the trig, it's not due to, I think the hard cutoff I wrote was on the Monday. And this is the logic behind it. On Monday, I am putting a chapter 4, chapter 5 quest, and I'm releasing it live on our Google Classroom. I don't want people to have so many assignments overlapping. And so to sort of encourage you to time manage and chunk, I guess, deadlines without overlapping, I'm sort of forcing it to be done by Monday. If you have it done a little later, it's not a big deal, but I am concerned, so I'm just trying to force you to do it by Monday.
And
Does that
sorry,
make
how long do you have for that quest?
Okay. Well, I'm going to have more details. I'm probably going to release it on Google Classroom, so hold tight. But if you are interested, I am giving you all of next week to do that quest. But you have to do the quest that week. After Friday midnight of next week, I am closing all submissions for the quest. The logic is this. We don't have time to do any kind of test in class right now, so I am letting you do it, do a quest, sort of like a project assignment at home. However, it is not fair that I make this quest be done from like 6 to 7:30 on Monday, because you might have a prior engagement. Let's say you have, swimming on Monday, and then you have babysitting on Tuesday, and then on Wednesday you do this, or you volunteer at a church, and Thursday you do that, and it might be a little tough for you to time manage and figure out a day, a specific like hour in a time slot in the evening. And so I am going to release it and let you choose a time, but it has to be sometime next week. I think that's reasonable, and I feel like I am meeting you halfway there. For you specifically, because you have your asynchronous day Monday or Tuesday, it might be a good time for you to plan to do the quest during that asynchronous period since you're supposed to be doing math anyways. But I'll leave that to you. Please like organize a time where you can do a math quest on sometime next week. Any other questions? I have a question that says, will you be posting any review for the quest, like for us to do over the weekend before the quest? I've been assigning a lot of homework questions from the textbook. I think there's more than enough for you to do there to keep you busy. If you want a pointer of what might be on the quest, I will share that with extra information on an announcement on our Google Classroom stream. Okay, the things that you ought to focus on. But Chapter 4 and Chapter 5, there wasn't a lot. It's just the material is new, and so it's a little bit, it could be confusing. So if you look at it, it'll just be like, oh, this is just pastoral stuff. And in Chapter 5, it's like, oh, it's just graphing a sinusoidal function. So there's not that much, so you can expect some just limited concepts, but different styles of questions will be there. So just do the homework questions. It'll give you a good spread of types of questions that could be on the quest. Okay, with that said, if you have any other questions, please, you could send an email or whatnot. It is 3:16, so I am going to dismiss you. Please give these textbook questions a shot. It will help you be more than prepared for tomorrow. Okay? At which point I'm going to get you to do an assignment during our hour 15 period. Okay? All right. See you tomorrow. You are dismissed.
Jim, see you tomorrow.
Thank you.
Bye.
Bye. Thank you.
Bye.
Thank you.
See you later. How creative artistic does the optional assignment have to be? Have some color and have a theme. Done. Okay. If you've got if you want to use it as like a snowboard jumping hill, sure. Okay. If you want to just, I will be impressed with anything. Just add some color.
Mr. Kim, I was wondering if I could talk to you for a second.
Yeah, sure. Go ahead.
So tomorrow, I'm in an online debate tournament all day, so I'll be unfortunately missing tomorrow's afternoon class, and it sucks that there's an assignment tomorrow. So
Oh,
is there any way I can make that up?
no, absolutely. No, it's not like it's due at the end of class. Don't think about it that way. But it's so straightforward and simple that you'll be able to complete it. So what I would recommend you do, you probably have the handout already, yes?
Yeah.
Okay. So what you're gonna do is the front page, you can watch my YouTube video and see exactly what's happening. And then you just follow the instructions and do your thing with the back page, and then you can submit it online.
Okay.
Or you could submit it in class on Monday. Not a
Okay.
problem.
Okay. Sounds
All right.
great. That's
No.
okay. Thank you. Have a good
All
day.
right. You too.